Okay, hello everybody, welcome to my review for the Double Horse 9100. It is a 3-channel fixed pitch helicopter. Unlike coaxial 3-channel helicopters where the forward and backwards movement is provided by a vertically mounted tail rotor which tilt the aircraft forward and backwards. This helicopter actually takes a page out of 4 6-channel helicopters and uses a servo to control a swash plate to allow forwards and backwards movement. So getting this helicopter gets you more skilled with the way that 4-channel and 6-channel helicopters operate, but still it's simplistic enough that you can fly it as a beginner right out of the box. Some of the first impressions I had, obviously this helicopter's had a couple modifications and been flown for a bit, has a few repairs done on it already, is when I first took it out, I'm happy with the metal construction, metal frame, metal tail boom. I was surprised to see that all of the linkages and the swash plate is all plastic, but so far it seems to have been holding up very well. The canopy is not the normal really flexible thin plastic that you find. It's more of a solid plastic and is prone to breakage, especially with the weighted fly bar, and that has a tendency to smack the canopy when you run into something or have a crash. So my canopy has a few cracks in it, and actually a significant crack down the side, which I've repaired, but you know, when you get into this stuff, you're going to be repairing your helicopters about as much as you're flying it. So, the other thing I can say about this is that the when you first take it out of the box, it's not going to be very controllable. You're not going to have much forward movement at all, and that's due mainly because of the swash plate design they have. And the swash plate is this round section which encompasses the main rotor shaft, and that's what allows your linkages to adjust based on the pitch of the swash plate. And this one, let me take the canopy off here so you can get a better view of this. Alright, there we go. And you can see I've already modified my swash plate. I still have an original one that I'll show you here. This is what the original swash plate looks like, and if you look at it, this is the bottom view. You have your ball joint here, which connects to your servo arm for your forward and backwards flight, and this swash plate, instead of pivoting on the main drive like most do, it pivots on a separate set of ball joints which are all the way up forward here. So if you're holding it and you look at that pivot and you move this up and down, you can see you're not going to get that much angle change for how far you move it up and down. And that's what's really limiting your forward and backwards movement out of the box here. So what I've done as a modification is I've taken a rotary tool. And you can buy these pretty cheap, or you can just use a hobby knife or something. But what you want to do is you want to cut these 2 ball joints off. Don't cut off this peg sticking out here. That's what keeps your swash plate from rotating around and just going out of control. But you want to cut those 2 linkages off and just sand it down a little bit, and you're going to re-glue them back more so the balls are in a 90-degree line of your axis to where your actual control arm is for your swash plate movement. And since you're moving your pivot back more to where the axis is, you're going to see that same amount of movement is going to allow a much greater swash plate angle change. And it's all about the angle of the swash plate, and that's the more angle you can get out of your swash plate, the more forwards backwards control you're going to have, the more overall speed you're going to have. And I'll show you what it looks like now. These dog bones used to be mounted to the front off of that screw, and it would go straight up, and that would control the old pivot point. But what I've done, I've drilled a new set of screw holes back here, and attach the dog bones there, and you can see that my pivot is now in the center of my swash plate. So now when I move it, you can see I get much more swash plate movement there. And I left my dog bones a little loose because I didn't put my pivots perfectly center to where the pivot is on the actual rotor shaft, but that's fine. Like I said, I left it a little loose, that way it has a little play for the dog bones to move forward and backwards. So that took care of my forward movement for the most part. A lot of people are still adding a little bit of weight to the front of the canopy. That's fine, but you're going to sacrifice your backward speed or your braking ability. I didn't want to do that too much. So, I mean, you just got to be aware that you can't fly this in very high wind speeds. Sorry about that. The next thing, we're going to talk about the actual motors here. Not sure what these are, what size motors they are, but they are brushed motors. And what that means is they are prone to overheating and failure. A lot of model helicopters now use brushless motors. They're much more powerful for the weight, and they save your battery a lot more. I'm not sure if I can fit a brushless motor in here, but if I do decide to do one, I'll post another video review of that. But basically it does have a main motor which controls your main rotor drive, and you have a separate, instead of a shaft driven or a belt driven, there is a separate tail motor. As far as ease of maintenance and operation, I can see why they went this way. It does make the product cheaper and a lot easier to maintain with a separate motor. If you ever have a failure, you're just going to detach this tail section, remove the motor, and replace it. Whereas if you have a belt driven system or a shaft driven system, you would need all kinds of linkages back here, just like you have your linkages up here to control your blade pitch and everything in the tail. So this is a much more simple design, especially for beginners, just to get in and learn the fundamentals. We have the primary flight board here. Not many wires are soldered on, just it looks like your power is soldered on. Everything else is done through connectors, which is great. Everything looks pretty robust. Looks like it has the ability to cool very well, so you shouldn't have any overheating problems here. Going down to the battery, let me go ahead and disconnect this and pull it out here. Bear with me a second. Okay, mine's being a little stubborn. There we go. Okay, this comes with a, sorry it's dirty, there was some two-way tape on here that I removed to see the label. It comes with a 7.4 volt, 650 milliamp, and though a lot of sites advertise this as a lithium polymer, I don't think it's a LiPo battery. I think it's a I don't think it's an NiCad either. I forget what the step is between. There's like a lithium ion, I think. That might be what this is. But it's only a 650 milliamp. Let me pull this up here. It's scale. And we're just going to quickly weigh it here. Let's put it on grams. Here we go. Okay. And you're going to see it's going to come out to 46.8 to 47 grams. And a quick search online tells me for 47 grams I can actually fit a 1000 milliamp lithium polymer, which has a lot better life expectancy, and the 1000 milliamps will give you better flight time. But again, since this is not a brushless motor, the extended flight time could burn out your motor. So just be careful. I mean, if you want to get the 1000, certainly. I opted to get the 800 milliamp to give me a little bit more flight time, but more importantly to reduce some weight. The 800 is scaled in at about 41 grams. So I'm saving about 5 or 6 grams of weight here. Okay, we've gone over pretty much most of the stuff on the helicopter here. You will notice there are some other modifications I've made. I've taken off the actual decorative support bar and the one of the tail fins. A lot of people remove both of these fins just to save weight. I keep this one on just to protect my tail rotor when I'm landing and taking off on hard surfaces. I don't want it grinding. So I'd opted to leave this one on. But removing the weight from the tail does help. I mean, it obviously makes the helicopter itself lighter, but it slightly moves my center of gravity forward, which helps my forward movement some. But again, moving your center of gravity forward helps your forward movement, but it also decreases your ability to stop or slow down. But you can find a happy medium just by playing around with it. Moving on to your actual transmitter. It's a nice looking 3-channel remote. The left stick does look like it has a 4-channel, but it's not. It's locked in, so it's only, and so is your actual trim adjustment that's locked in as well. So it is only a 3-channel remote being masked as a 4-channel. The one thing I don't like about this, since it's not digital, all your trim controls, you can change it, and once you start your helicopter back up, you're going to lose your trim controls. But I mean, that's not major. We're talking about a $35 helicopter here. It is in the 49 megahertz range, so you do have to deal with the large antenna as well as your actual wire antenna on the helicopter. It would have been nice if they went to 4 gigahertz, but I guess just for pricing, they opted to go with the 49 to 50 megahertz. The 9116, which is basically the same helicopter frame but a 4-channel, does fix this. It is a 2.4 gigahertz and it offers 4 channels of control, but that'll be a separate review. But as far as this transmitter, it's very basic. You got your on-off, you got trim controls for each of your methods of control. Just a little decorative LED screen. It really does nothing. And you also have separate forward controls and left-right balancing, or not balancing, trim, that allows you to adjust these, and then you can adjust these separately for more fine-tuning. But that's that. Overall, as long as you're willing to do some modifications, it is a fun helicopter, and it does teach you some of the fundamentals. But for the more experienced flyer, you're probably not going to like this model. You're probably going to want to go with the 9116 just because it does offer the digital transmitter to 4 gigahertz technology and 4 channels of control. 2 channels on your actual swash plate, so you get your left, you get your strafing, your left and your right movement, whereas this one, you have to look in the direction of travel in order to move that way. But overall, it is a nice buy. I do recommend it to start off, just so you can start learning your controls and the fundamentals of swash plate. Whereas a coaxial, you're not really going to learn much about swash plate and how that affects your flight. Some of the other things I do recommend you buy, and you can get all this off of Amazon or online. Digital scale, just so you know what weight you're taking out of it and putting into it and all that. Something I forgot to mention, I do want to say, this helicopter, I have put about 17 grams as far as payload on it, and it has still maintained a fairly high amount of control, so I wouldn't go much higher than 17 to 20 grams, but you can, for that weight, put on a wireless camera system if you want. And I got this off of Amazon, and I've quickly looked at it. I haven't had a chance to mount it or do any extensive tests on it yet, but it does prove promising. And after some modifications, this camera weighs in at only 9 grams. So obviously well within your 17 to 20 gram limit, or gram limit. I'm sorry. Some other things you're going to want to pick up is some adhesive, some glue, because you are going to crash and break this thing. These are the two I use. We have a 15-minute set time on this one, and the good thing with this is you can use it for metal, plastic, whatever. It's not limited to just plastic to plastic bonding. This one I use for whenever any of my plastic or metal breaks. It has a 15-minute set time and it dries hard. It is sandable and it's very strong. I love this stuff. This is what I use for repairing canopies. It has a 5-minute set time. That's a little over advertised. I'd give it more 10 to 15 minute set time. And it dries somewhat hard. It's a little bit flexible, kind of gummy, which is why it is perfect for these canopies here. You can see I've already made some repair there, and it flexes. It's not going to crack or chip when the canopy flexes, and that's what you want. Otherwise you're going to be repairing it every time you fly it. Of course, I have the rotary tool as well, and that's just if you're going to get into any heavy modifications like I've done with the swash plate. But other than that, like I said, it's a great value and it's a great beginner flyer, and it's pretty easy to get your money's worth out of this helicopter, especially if you're willing to sit down and make the simple modifications I have.